3.1, simplifying expressions with exponents. So this is really an exercise in do you sort of feel comfortable with the rules, and can you see sort of little patterns and things like that below. And one of the reasons we do this is because in calculus it really helps if you can fluently move from one form to another. So I'm just going to do some examples and see where we get from there. So I'm looking at this mess over here, and there's not a whole lot that I can do with that because like 2 is prime, but 4n, well, 4 is 2 squared, so I could think of that as a 2 squared n on n. And then 2, well, that brings everything over here in a base 2, so let's put an exponent on that and see what that brings me. Well, 16 would be 4 squared, but 4 is another 2 squared. So this is actually 2 squared to the power of 2, and then, so it's actually 2 to the 4th. Now, some of you might recognize 16 immediately as a 2 to the 4th. The reason we want this as a 2 is because now all of this is in base 2. And if the bases are the same, then you can somehow combine all these into one expression. So let's see what we have. And I did forget the end there. So the 16 was 2 to the 4th, and then we needed an n there. So we got a 2 and a 2n. We don't have much there to do yet. And then that's another 2n. And then that's another 2, but now to the power of 1. And then here I can multiply exponents as well, so that's 4n. And then I'm initially going to look at the top. All these can be added, so this is actually 2n plus 2n, which is 4n. That's a 2 to the power of 4n times a 2 to the first. Actually, I'm going to leave it like this because you can actually see that 2 to the 4n cancels itself out. So the final answer is 2 to the first, which is just 2. So that mess up there actually is just a 2. Okay. Well, initially, it doesn't look like you can really do this, because 9 can't be written as a base 5, and 15 can not be written as a base 5 or a 9, but somehow this stuff should ring some bells here. Now, the first clue there is that is a 9, and you see a 9, and hopefully at some point you'll start looking at that as, well, 9 is actually 3 squared. So let's see what that, and I'm going to put it over here initially. Let's see what that would allow me to do. So actually I'm going to write that as a 3 squared. And so the 9 had an exponent of x minus 2. Okay, so there's step 1. Well, 5 and 3, that makes a 15. So let's split this 15 in a 5 times 3, and that's 15, and then a 2x minus 3. Okay, distribute the 2, or the x minus 2 back in here. So I can rewrite the top there as a 5, 2x minus 1. And then this 3 should have an exponent that looks more like 2x minus 4. Then this can sort of distribute to both of those as well. So that's a 5 and a 2x minus 3, and then that's a 3 with a 2x minus 3. Now let's combine them sort of just in pairs. So what I have is a 2x minus 1. And when you divide exponents, so keep in mind that the rule is that if you divide exponents, or like bases, so 5 to the 3rd, and then a 5 squared, the shortcut to that would be to do like 3 minus 2, right? So that's what I'm going to do here. I'm going to subtract the bottom one. So I'm going to do subtract 2x minus 3. And I need to do the same thing for the other one, because that's both in base 3. So times, and then 3, and I have a 2x minus 4. And from that, I need to subtract the bottom exponent, and the bottom exponent again is 2x minus 3. And then I should be pretty close to being done. So let's see what happens here. That's 5, so 2x minus 2x is 0. And the negative 3 makes it a plus 3. So it's actually a negative 1 plus 3, that makes it a 5 squared times 3. 2x minus 2x is 0, and then this negative and that negative make it a plus 3. So negative 4 plus 3 is actually a negative 1. And so my final answer is going to be 5 squared is 25, and 3 to the negative first is actually a 3 in the bottom of a fraction. So this becomes 25 over 3. So hopefully that's right. Okay, next one. So now we're going to combine this a little bit with factoring. And so you may wonder, well, how do you mean factoring here? Well, I see a 2t here and another 2t, but then subtracting something, and then that's a 2t and that's a 2t. I think somehow I can do some stuff with that. So first, let's rewrite this one. So this is a 2t times a 2 to the negative second. if you multiply like basis, you add exponents. So that should give me 2 minus t there. So that's the same thing. And then here, if I take the 2t out, that leaves, so if I took it out here, that leaves just a 3 minus, and then since the 2t came out to the front, that leaves a 3 minus a 1. And 3 minus 1 is just 2, I think, right? Okay. Well, now I can do 2t over here, and I can take that out, so 2 to the power of t. So that leaves you a 1 minus 2 to the negative second, divided by 2t, and 3 minus 1 is 2. So those cancel. So that becomes 1 minus, and that's actually a 1/4, divided by 2. So that's 3 over 4 divided by 2. So that becomes 3 over 4 times the reciprocal of 2. So think of 2 over 1, so that becomes 1 over 2. So my final answer for this one is 3 over 8. Okay, last one. This one's a little trickier, but there is something here that should draw your eye a little bit. 9 and 3. 9, again, 9 was 3 squared, right? So 9 is 3 squared. So I'm going to rewrite that. I'm just going to say, well, let's say 3 squared to some power of x minus 1. And then over here, there's not much I can do right now. That's 3x plus 1. And then this is where the trick comes in. So I'm just going to swap exponents there. So that's a 3 to the power of x. So the x is now here. So let's put the 2 here. Minus 1. Well, now I'm squaring something. What I'm squaring is 3x. So think of this as a 3x squared minus a 1 squared. So that's actually like having a squared minus b squared. Well, those things are factorable. That will be a minus b times a plus b. That's what I'm going to do here. I do need to keep in mind that I do have a denominator at this point still. So what do I have? So that's a minus b, so that's a 3 to the power of x minus 1, times an a plus b, so that's a 3x plus 1. All of this is divided by 3 to the power of x plus 1. And then you can see those cancel. And so your final answer here will be that this simplifies to 3 to the power of x minus 1. And that's it. Thanks.